Okay, so in this video we're going to be continuing with limits, and specifically we're going to be talking about piecewise limits. Okay, and these obviously include piecewise functions. Okay, and if they includes piecewise functions, you might imagine that we're going to be doing a lot of one-sided limits. And since we're going to be doing a lot of one-sided limits, I want to visit a rule that I happen to mention uh, before. So that rule is the limit as x approaches a from the left of some function f of x. If that limit is equal to the limit as x approaches a from the right of that function, and let's say those limits, since they're equivalent, they're going to be equal to some value. Okay, if that's true, then the general limit as x approaches a of f of x also exists, and it is equal to L. And on the flip side, we have the limit as x approaches a from the left of f of x does not equal the limit as x approaches a from the right of f of x. Okay, so if they're not equal, well then we know that the general limit as x approaches a of f of x does not exist. Okay, and with that being said, I also want to say that the opposite is also true. So reading this way is true, but also reading it this way is true. Okay, so if the limit as x approaches a just in general exists and it is equal to some number, then of course the limit from the left and the limit from the right also have to exist, and they also have to equal that same value L. Right, so this rule works backwards as well. And same thing for this one. If the general limit as x approaches a of f of x doesn't exist, well then the limit from the left and the limit from the right, maybe not, they don't exist, but they are not the same. Okay, and that's what this obviously says on the left. Okay, so these rules work backwards as well, and we're going to use that to help us solve piecewise limits. Okay, so let's kind of go through that real quick. Okay, so let's say I have some sort of a function, call it f of x, and it is defined in three different values of x. Okay, so three different domains. I have in one, it is defined as 1 over x plus 2. In the other, it's defined as x squared minus 5. And finally, it can be defined as the square root of x plus 13. Okay. And for 1 over x plus 2, that is whenever x is less than negative 2. And for x squared minus 5, that is when x is in between negative 2 and positive 3. And then for the last one, it's whenever x is greater than 3. Okay, so as you can imagine, the interesting parts, or where we want to find limits, are probably going to be at maybe negative 2, because that shows up, and positive 3, right? I could ask you to find the limit as x approaches 0 if I wanted to, but that's not really interesting. Okay, because at 0, well, that's in between negative 2 and 3, and that's just defined by x squared minus 5. We know how to find that limit. It's easy. We just substitute in 0 and we see what it's equal to. Okay, but we don't want that. We want the limits at negative 2 and a positive 3. So let's write out our limits. We're going to have the limit as x approaches negative 2 from the left. Okay, and when we say from the left, well, what is our function equivalent to for values of x that are less than negative 2? Well, the function is defined by 1 over x plus 2. Okay, and likewise, if we're finding the limit as x approaches negative 2 from the right, well, what are values, or sorry, what is our function defined by for x values that are slightly greater than negative 2? Well, it's going to be defined by x squared minus 5. And finally, if we can find those two limits, well, we can find the general limit as x approaches negative 2 of just our general function f of x. Okay, and we can also write our other limits that we're going to probably try and find, which is going to be the limit as x approaches positive 3 from the left. Okay, and when we're approaching positive 3 from the left-hand side, what is our function defined by? Well, it's defined by x squared minus 5. And as we approach the limit as x approaches 3 from the right hand side, what is our function defined by for x values slightly greater than 3? Well, it's defined by the square root of x plus 13. And if we can find both of those limits, we can find the general limit as x approaches 3 of our general function f of x. Okay, so let's start with this top limit. And remember, what we're going to do is we're just going to treat this one-sided limit as a general limit. So we're not even going to consider that we're approaching from the left-hand side or the right-hand side, unless we have to. Okay, so we're just going to try and solve this as if it was a general limit. Well, if this was a general limit, first thing I would try is substitution, right? Well, substituting in -2 wherever I see an x, that's going to get us 1 over 0. Of course, we don't like 1 over 0 in the denominator, can't have that. So what would be my next step? Well, my next step would probably be to start factoring. Again, here, I can't really factor anything. So what would be my step after that? Right, I can't factor. What's the next step? Next step is to do a sign analysis test. Okay, so let's do our sign analysis test. And remember, for that, all we do is we take a number line, okay, and we put our important numbers down here. Our important numbers are, we take the numerator, set it equal to 0, take the denominator, set it equal to 0, whatever x values we get, those are the ones we're using. In this case, just our denominator has an x in it, and we get x equals -2. Okay, and now we do our sign analysis test. Since we're approaching from the left, we're going to choose a number less than -2, and we're going to see what is the sign of our function. Well, the sign of our function, let's say we choose -3. That's a nice number. We're going to get 1 divided by -3 plus 2. -3 plus 2 is -1. 1 over -1 is a negative number. Okay, so I get a negative. What does a negative mean? Well, that means that I'm going to go down to negative infinity. And so what we can say is that this limit is equal to negative infinity. Now, let's find the limit as we approach -2 from the right-hand side. Now remember, from the right-hand side, we're not going to do a sign analysis test because it's not defined by the same function that is on the right-hand side of -2. It's not defined by 1 over x plus 2. It's defined by x squared minus 5. Okay? And again, we're going to go through this process as if we're finding a general limit. So we don't even care that it's from the right-hand side. We're just going to substitute in -2. Right? We always try substitution first. Well, let's try it. You substitute in -2, you're going to get -2 squared, which is 4. 4 minus 5 is -1. We know that we can solve this because it's just a polynomial. We know how to solve polynomial limits. And we get -1. It's as easy as that. And now we can answer the general question. Well, does the general limit as x approaches -2, what does that equal? Well, in this case, since the limit from the left and the limit from the right are not equal, the general function, the limit of the general function, does not exist. The limit from the left exists, it's going to negative infinity. The limit from the right exists, it's going to -1. But the general limit does not exist. Okay? So let's move on to the other set of limits we have to find, and that is when we're approaching 3. And remember, we're going to look at these just as general limits. So what is the limit as x approaches just 3 of x squared minus 5? Well, that's easy. That's just a polynomial. We're just going to substitute a 3 into there. We're going to get 3 squared, which is 9. 9 minus 5 is 4. Easy. Okay, what is the limit as x approaches just 3 of the square root of x plus 13? Well, we know that we can take these square roots and turn them into exponents, and then take exponents and put them outside of our limit. And once we do that, well, now again, we're just dealing with a limit that's a polynomial. We know how to solve those. We substitute in. We're going to get 3 plus 13, which is 16. Square root of 16 is also 4. And in this case, our limit from the left and our limit from the right is equal to the same value, and therefore our general limit is equal to that same value, in this case 4. Okay? And now if you're wondering, well, okay, this is nice, this is cool, but what does this actually look like? What does this actually mean to get these numbers, these values? What does it mean to get does not exist? Well, I actually have an image here of the function. Okay, so this is what the function that we have up here, this piecewise function, okay, this is what it actually looks like if you were to draw it. Okay, and you can see here at the value of -2, okay, the value of -2 from the left hand side of -2, we're actually going down to -infinity. But on the right hand side, we are going to the value of, okay, the value of, well, what value is that? If we go back up here, we see that that value is -1, right? So the y value is equivalent to -1 when we approach an x value of -2 from the right hand side. Okay, and then here when we're approaching 3 from the left hand side, when we approach 3 from the left hand side, we're getting to this value of, draw that a little bit more accurately, we're getting to this value of 4. And when we're approaching from the right hand side, we approach that same value of 4. Okay, and so that's what it actually means to have this does not exist, -infinity, or to have them converge to the same point. Okay, pretty cool to actually see that. Let's go over one more example of piecewise defined limits. So let's say I have a function, again, f of x, and again it's going to be defined in 3 different areas. In one it's just going to be x squared, in the other it's just going to be x, and in the last one it's going to be 2x minus 1. Okay, this one is going to be a little bit easier to solve, and our domain is going to be x less than 1. Then it's going to be when our x is in between +1 and 2. And finally, it's going to be when x is greater than 2. Okay, so again, where are we going to be finding our limits? Well, we're probably going to be finding our limit as x approaches 1. Again, that seems like a pretty important number. Okay, so as we approach 1 from the left, okay, what is our limit as x approaches 1 from the left? What is f of x defined as from the left hand side of 1? So for numbers less than 1, well, that's going to be x squared. Okay, so we'll find that limit. Then we'll find the limit as x approaches 1 from the right. Okay, and on numbers slightly greater than 1, it's going to be defined as just x. And then our general limit as x approaches 1 generally of f of x. And obviously we have our other limits on the other side, which is going to be the limit as x approaches 2, right? That's the other important number, 2, from the left-hand side. So on the left-hand side, it's defined by just the function x. And the limit as x approaches 2 from the right-hand side, so for numbers or values of x that are greater than 2, it's going to be defined by 2x minus 1. And then we can find the general limit as x approaches 2 of f of x. Okay, so you'll find that this one is going to be a lot easier to deal with because quite simply all of these are polynomials. Okay, and remember it's really easy to find limits of polynomials. And we're not necessarily finding the limit as x approaches 1 from the left, we're just finding the general limit. Okay, so the general limit as x approaches 1 of x squared, well, we're gonna substitute in our 1. 1 squared is 1. And the general limit as x approaches 1 of the function x, well, that's just equal to 1 as well. Well, if our function from the left and our function from the right are equivalent, in this case they are, then our general limit is going to be the same. It's 1. Pretty easy. And if we move on to this one, well, again, we're just going to do these as a general limit as x approaches 2 of the function x. Well, that's just going to equal 2. And the limit as x approaches just 2 of 2x minus 1, well, that's going to be 2 times 2, which is 4. 4 minus 1 is 3. Now in this case, our left-handed limit and our right-handed limit, they don't exist. And if they don't exist, well, then the general limit does not exist. Okay? Now again, you might be asking yourself, okay, this is cool. Pretty easy to find the answer to this one, I think. But what does it look like? Maybe you're curious. Well, let's take a look at what it looks like. Down here, we actually have an image of it. Okay, so this purple one is what our function looks like. And as you see here, when we are approaching from the left-hand side of 1, we get to this value, which is equivalent to 1. And when we're approaching from the right-hand side, we get to that same value. And so when we go and take a look at our limits here, the limit as x approaches 1 from the left and from the right is equal to 1, and therefore the general limit exists and it's equal to 1. But as we are approaching 2, what you'll notice is that as we approach 2 from the right-hand side, we're approaching this value, which in this case is equal to 2. But as we approach 2 from the right-hand side, we're going to get a different value, in this case 3. So there is a jump from 2 to 3. Okay, and since the limit from the left does not equal the limit from the right, well, therefore the general limit does not exist. Okay, and again, that's exactly what we got up here. The limit from the left was equal to positive 2, and the limit from the right was equal to positive 3, but the general limit does not exist. Okay, this graph explains that very nicely, or shows us that very nicely. Okay, so that's everything for piecewise limits. Remember, in order to deal with them, all you have to do is just make sure you have the right functions written down when you're approaching from the left and from the right, and then when you're actually solving those limits, just solve them like you would a normal limit. Okay, don't think about it as from the left and from the right, just solve them like a normal limit, see whatever answer you get. If the limit from the left and the right is equivalent, well, the general limit exists and it's equal to that value. If it's not the same, well, then the general limit does not exist. Okay, so that's everything for this video. In the next one, we're going to get into some very interesting stuff, and that is limits of trigonometric functions. So that's coming up in the next video.